All right. All right, it's been a long time since I've done a video, and basically I've just been swamped. There's lots of stuff going on. Lots of good stuff. We're doing a lot of interesting stuff, and I'm going to share some other things with you at another time, but I want to get right to responding to a friend of mine, Ketan Panchal in India, who first wrote me on November 15th with this question, and then reminded me again on November 21. So, Ketan, I'm really sorry. I apologize for that. Happy Diwali to you too. I appreciate that, and Happy New Year. So, I'm gonna read your question now, and then I'm gonna give you some concepts about it. Okay? All right. So, my friend Ketan writes, "Dear sir, Happy Diwali and New Year, and Happy Diwali to you too. In CI Flexo, we print white on natural 50 micron PE, polyethylene, using 112 LCM/cm cube/m square anilox. In this condition, we are facing pinholing problem in white. Kindly give me suggestion to remove pinholing. Thanks in advance with warm regards, Ketan Panchal." Okay, Ketan. Now, the first thing, you're saying you're using a CI Flexo press and you're printing white. And you're talking about 50 micron PE polyethylene, so you're talking about a very thin gauge polyethylene. And then you describe that you're using the following: 100/12 LCM/cm cube/m squared. All right. So let's clean that up a little bit so that some of the other folks around that may be watching this video can understand that. All right. Excuse me one second. Okay. Ketan has written up here 100/12 LCM/cm cube/m squared, right? So I think I'm going to decipher that as being this. This is 100 lines per centimeter, 12 cm cubed per meter squared. Now let's take that over here. Cm cube is a centimeter cube. So that's 1 centimeter by 1 centimeter by 1 centimeter. Okay? So what you have here, 1 centimeter by 1 centimeter by 1 centimeter, that happens to be 1 cc. And m squared is meter squared, m squared, that happens to be the metric equivalent of what in the United States and many other places we call, is BCM. Now 1 BCM does not equal 1 cc per meter squared. But where some folks in Europe and in India and other places use metric nomenclature and refer to lines per centimeter and to cc's per meter squared, in other countries we use BCM, which is billion cubic microns per square inch. So so what we've got here, it looks like is a 100 line per centimeter, 12 cc per meter squared. Okay, that happens to be a very, very high volume situation. Now, but volume can go higher. And the problem that Ketan says he's having is that it's pinholing. Okay, we're going to talk about that in a second. But also for the benefit of folks that use BCM per square inch, let's turn that into that for a second. Now, I don't know when I did it, but at some point over the past many years, I developed a conversion factor between BCM and cc per meter squared. So I'm going to assume that it's right, and I may be proven wrong. But what I think I figured out was that in order to get cc, in order to get that, you take if you want to get cc per meter squared, you take BCM and divide it by 0.655 0.6416, okay? That gives you cc per m squared. Can you see that? Yeah, okay. All right. So now let's do it. Now let's do the other thing. If you have cc, which is what we have here, we have cm cubed per m squared, so which is cc per meter squared. If you have 12, what we do is we multiply that to get the BCM. So 12 times, so let me write that down just so you have it, okay? Let's do that real quick because I think a lot of folks might want this, all right? All right. To get cc per m squared, take BCM divided by 0.65416, okay? All right, get that because now I'm going to erase it. To get BCM per inch squared, take cc and multiply it by 0.645, So this is the conversion factor. You're either going to multiply by that number, to multiply cc by the number to calculate BCM, or divide BCM by that number to calculate cc's, okay? So I'm pretty sure that number is correct, and if you find out it's different, that's your homework, and you can let me know if it's not. All right? All right. So then what do we have? You have 100 L lines per centimeter, right? Lines per centimeter. That, by the way, folks, it translates to 254 lines per inch. Okay. All right. That's on the lower side. You could go lower than that, you know, 180 and even lower than that when you're throwing coatings down. But that's plenty low. You should be able to get a good white film down. Okay. So what might be happening? One thing is that your anilox rolls might not be in good condition. Okay. If you have either because the manufacturer of the making of that anilox is defective or poor quality, or because there's wear or something like that, in addition to the fact that you have a low line count anilox, which tends to make so that the spaces between the cells, if you will, that's a simplistic drawing, but the wall tops and what's called the posts, the interstices between the flat areas between cells, those areas, those land areas are larger when you have lower line counts, okay? So you could be applying significant volume, low volume, significant volume, low volume, and perhaps if you take a good look under magnification, you might be able to observe a pattern. That might be one thing to look for, okay? Now,